I'm Colleen Rosales. Hi, I'm Colleen Rosales. I'm the Strategic Partnerships Director at OpenAQ, a US-based nonprofit, and you will learn more about OpenAQ in a little bit. Thank you.
Thank you. Olamide Aziz. Tinoluwa Odugbemi.
Hello.
Hello.
Hello, can you hear me?
Yes, we can.
All right. Good afternoon, all. So I'm Dr. Odugbemi Tinola, commonly known as Tomi. So I'm a lecturer in the University of Lagos and associate professor in the University of Lagos. And I'm a member of different clusters. I'm a public health physician working with a lot of non-medical people. Thank you.
Thank you. Adefolusho Adebambo.
Good afternoon, ladies and gentlemen. Yeah, my name is Adefolusho Adebambo. Currently, I'm doing my master's in environmental management in the United Kingdom. Well, the name of the school is GCU, Glasgow Caledonian University, here in Scotland. And I own a company in Nigeria, Apparel Cleaners. It's a janitorial stroke environmental cleaning organization. Thank you.
Thank you very much. Comfort Samuel. Robert Ibiaki. Please, can anyone online on this and introduce yourself if you want to now? Okay, thank you. Can we just make a quick introduction here?
So you're welcome to this event. My name is Dr. Rose Rani. I am an associate professor at the University of Lagos, and I'm the PI of this project.
That is actually comfort. Don't worry. Without dignity, it's a perfect choice. Transport policy and safety. Well, we're doing introduction. Let's So, thank you very much, everyone, for being at this seminar, webinar. This webinar is about providing open and universal access to global health information. And as we all know, that when it comes to pollution, transportation is about the third phase. So one of the things that the managing director of the matter is passionate about is anything that has to do with sustainable transportation. When I mean sustainable transportation, we're looking at how we can reduce emissions on all our public transportation. And that is why we have our blue and red line, we have the BRT process, we have initiatives that has to do with non-motorized transport, anything that has to do with reduction of air quality. So I would like to humbly invite the managing director of Lamata, engineer Mrs. Abimbola Akeaje, for the welcome.
Afternoon, everybody, and I'm particularly delighted to welcome the professors and students and lecturers from the University of Lagos. That's my alma mater, so Unilag will forever expect to turn out amazing students, if I say so myself. Okay, so we're here to talk about providing better air quality for us in the city of Lagos, and I really welcome the opportunity for us to discuss and hopefully come up with initiatives that can be utilized, especially in the transportation sector. Yeah, warmly welcome to Lamata. Lamata has the responsibility to plan, to implement, to regulate, and to franchise public transportation. So when you look at the world statistics, it says that we really are responsible for the worst of air pollution. So I think us having this discussion here makes a lot of sense. And us having that discussion with brainiacs like yourself also makes a lot of sense. We would really like to hear and to discuss and to rub minds with you, such that we can take valuable insights away from this sort of collaborations and discussions. And I am hoping that this will not be a one-off. It will be a relationship that will foster and develop and hopefully lead into better things. I think we need to begin to own our space. We need to begin to be able to do things for ourselves, so that everything we do does not have to be imported. A lot of times when we talk about, when the world speaks about air quality, they're speaking from the perspective of the global north. And I believe that the global south needs to begin to take ownership of its own narrative. So we had a conversation the other day amongst ourselves, talking about this, and I said, when the global north is talking about the emissions from a Toyota car, they have not seen the info yet. The emissions that they imagine can never be what we are actually. So no matter the statistics they're spewing out, it really cannot be anywhere near what we are experiencing. And that's why I feel that the ability to own our own narrative will be excellent for us, especially now that the world is talking about trading carbon credits and all sorts of things, and we're constantly looking for money. And if we can begin to understand high capacity analogy somewhere at the conference I was at, that we can have quick wins. We can have quick wins because we still run gaps. So we run very small capacity public transportation. We run 100,000, more than 100,000 apples, over 50,000 peps, all pushing out. If we decide today that we're going to go all mass transportation, just by even if I end up using diesel vehicles, just by reducing my 100,000 to say 50,000, 20,000 vehicles, I will make wins that they could never make in 10 years. So we have the room to make very, very positive impacts on our own environment. And I think it's about time to start to take that seriously. So we're really very excited to have you here. I'm not going to stand here and talk to you about anything. I want us to speak together and listen to one another and hopefully develop. And this is not about we're going to learn something today. I am hoping that we will develop a relationship, that we will continue to utilize the brains that are coming from you and the practical aspects of what we are doing to develop positions that will hopefully inform those who are making policies, inform those who are making regulations, in the interest of the environment of the city of Lagos and hopefully just what I want to say more welcome and we'll sit down very quietly.
Yeah, welcome everybody. So I'm just going to set the ball rolling. Please a round of applause for our leader. I think you have seen the activity. Reading about, I just read about you and I, or just to get something really quick. So we're happy to be here, and I think the collaboration between the University of Lagos, specifically the Air Quality Monitoring Research Group, and the laboratory has been central in the MD ourselves. We just launched that now. So we'll just proceed. So next on the agenda was also having the DDC herself. That's the person of Professor Balawa. But unfortunately, she's receiving a vice chancellor from another university abroad, from UK. So she won't be here with us physically. So to introduce the project to our amiable MD, our lead, that's the person of our associate professor, Dr. Rosa, who will be introducing the project to give us the overview of why we're here today. So if your hands are not too busy, I will jump a little bit,
Thank you very much. And I want to really appreciate the MD just meeting you for the first time, and I love you so much. Thank you. And so can you?
Okay, go ahead.
Oh,
Yeah.
can you project?
I'm forward. Yeah. Forward.
Oh, forward.
Yeah.
Okay. Oh, we need to introduce this is Professor Bola Ogo, who is the DBC Academic and Research. So she and the other 3 DBCs right now are receiving a vice chancellor from another university outside the country, as Walter said. And then she should have been introduced earlier, and that is our MD here. So, and then this is Professor Ismail Ibrahim, who is the Afretech Network Coordinator for University of Lagos. Afretech is actually the one funding this particular project now. Afretech is African Engineering Technology Network. So he's going to join us online because he's also receiving that BC. And that is me. I'm not the one to introduce myself. And then this is Colin Rosales. She is going to speak on providing open air investor access to global air quality data. She's from Open AQ. She introduced herself briefly before. When she comes back, she will do further introduction and so on. And this is Titi Akosa. She's here in our midst, and she also has what to say. Yeah, this will be hearing a lot from her as well. And, this is not working. Okay, this is Dr. Davis Rene Segera from University of Nairobi, Kenya. He introduced himself earlier. He's really into artificial intelligence in electrical engineering, and he has a lot to also tell us today. Thank you for participating. I'm going to introduce this project. So I need my slide here.
Okay. Yes.
Okay. So this project is called Continental Digitized African Services Platform. And it's a project that involves partnership between three universities, three African universities. Just like the MD said, we have to do this by ourselves. So we have Professor Mohamed Sila from American University in Cairo, and we have Professor Albert Bresso from Kennedy University, Kigali, also in US, and then myself, University of Lagos. So, just to introduce this, it is an applied research typically solving the problem from society. I hope I'm not blocking it. Air pollution is much more severe agent in the global south. Pardon me if I keep on reading because I don't want to miss anything. Where growth of various cities and use of tertiary fuels and technologies is prevalent. The health burden from air pollution represents a grand challenge that will require significant international cooperation. So the severe lack of pollution, air pollution data around the world, and with the global mean population, so we don't have much data, especially in the global south. If you look at that map there, you can see a lot of that high concentration of monitoring in the global north, and you look at what we have there in the global south. So that's why we should sit up and do something, and that's one of the reasons we're having this project. So why now? Local source for quantifying pollution and identifying sources are being explored as a possible path forward in remedying the lack of data on the air pollution burden. Although significant knowledge gaps and barriers remain regarding the accurate application of such devices, I'm going to talk on this. The monitor density is high on the US and the global north, but not much here. So what we're talking about here is using low-cost sensors. Low-cost sensors, yes. And before we can use low-cost sensors and know that they are really valid and bring out good reports, we need to have what we call reference monitors. And reference monitors are really very expensive, but they bring out very accurate results. And so you can't have many reference monitors everywhere because of the cost. They range like from something $100,000 and so on, even more. So we cannot do much with reference monitors, but we can do something. We have low-cost sensors that are just ranging maybe between $2,500 to $5,000 and thereabouts. That we can use it so much and spread in a place like this and in Nigeria and other African countries where resources we don't have much, and so we can make do with the low-cost sensors. So where we really don't have much data here, and we're just starting. So we can use low-cost sensors. They're cheap. Spread them all over the place. If we can even follow transportation routes and some bus stops and so on, we can deploy low-cost sensors along where we want to monitor because they are cheaper. But they are not as reliable as the reference monitor. Not that they're not okay. They're okay, there will be some few deviations. And so what we do is to co-locate those low-cost sensors with the reference monitor. So if we have one reference monitor in Nigeria, that is something good. But for now, we have just two that have been running in Nigeria, one in the US consulate in Lagos, and another one in the US Embassy in Abuja. But we thank God for collaboration that in the University of Lagos, we were able to get donation from Afretech and donated 2 reference monitors to us. One for the particulates PM10, PM2.5, and the other one for the gaseous pollutants that's called AQ Sync, the one for particulates called feeders. So we have those 2 in the University of Lagos now. But we had some issues that slowed us down from installing them. Hopefully, next 2 weeks will not pass us what we install. And also, luckily, we had another project sponsored by the U.S. Department of State that enabled us to buy a third one called BAM. It's already here also. So we have 3, and we have a workstation for where we have reference monitors, those reference monitors, where people that are able to buy low-cost sensors can come and collocate there. Why collocation? You have to collocate and see the difference between the low-cost sensors values, data, and that of the reference monitor. And then we calibrate, validate, and get some calibration factors that we can use and know that if we get social value, social data from this local sensor, we apply this calibration factor, and then we'll be able to know exactly what to do to give us the exact data that we would have gotten if we were using the reference monitor. So we can now use the local sensors, spread it everywhere as we want to, and we'll still get the data very, very accurate, just as if we're using the reference monitor. So that's what I was talking about here. So for this particular project, like the MD rightly said, we know our own problems. The global north, the conditions there, everything there is different from what we have here. And you see, even when we're going through that heat waves, which affected everybody, even me, that they're not going through that over there. So the conditions here are really very different. And so the problems we have here, we have to solve it by ourselves. We cannot do it alone, like us in the research and in the management. So we have to come together, join our hands together, and be able to solve the problem. So in this case, we are the ones building the sensors. We want to build the sensors. The group here, the group I introduced to you when I started, the university in Cairo, American University in Cairo, and then the Canadian University in Kigali, plus University of Lagos. So we came together, but the Cairo University is the one designing and developing the sensor, building the sensor. Although we've been meeting together, having meetings together during the designing and so on, trying to give some good information that will help them to know exactly how to build it to suit us here. For instance, the power here, electricity, we cannot rely on that and say we're going to use local sensors that will rely on electricity if it not work. So I told them during the meeting that it cannot work here. So we must, even if we can use the electricity, we must also use alternative source of power, the solar power. So, and also data also is another issue, because for you to collect data, I mean, data connectivity is what I'm talking about now, that data, not the so connectivity is also another issue. So I also told them that when we're building these devices, we have to take into consideration connectivity. So we have to make it an inbuilt GSM system. So we don't need to be looking for Airtel, MTN, Wi-Fi to connect them. So it has to come inbuilt. So once we deploy, we don't have any issue with Wi-Fi. It keeps running. So, and then this particular sensor that we are building, it's gaseous. We're looking at nitrogen dioxide and ozone for now, and I was trying to get them to incorporate sulfur dioxide into it. And then just for a start, that's what we're starting with. And then what you will see then is just how our sensor is going to be built. So the obstacles, like I have already said, we have looked at the obstacles before coming up with this. We know we have that of the reference grade problem with the solution in our own case. We have some on ground, which in a few days or so we'll get them installed so that we can collocate by the time those sensors are here. They're not yet here, we're still building. And before I forget, Carnegie Mellon University is his own parties to their own parties to test. Hello, we design and build, but they cannot test. They don't have what to do in testing. So CMU will do the testing and make sure it runs well. They have everything to test. And we here in Unilab, we are good in coming together, relating with the policymakers, discussing and seeing how we can deploy and so on. So, and then we're going to deploy all those sensors in the 3 cities, here in Lagos, in Cairo, and in Kigali for a start, and then we expand from there. So, I've already talked about why the team, American University Cairo, is part of the development of nano photonics and so on. That's to simply that they want to design and build the sensors. Carnegie Mellon University will do the testing, and then we also will link local contacts, we link with how they can do what we're doing. Thank you.
So please clap for that. We don't clap like that. So that's the brief overview of the project. I see, because for you to solve problems these days, we need collaborative efforts. No one man is an island of knowledge, so you need to come together and solve one common problem. So, for anyone, any question for the day researcher? Anyone? Question, observation, comments?
Yeah, of course.
Okay. You kindly introduce yourself, your name.
Just get interesting. So you mentioned that so for the outside, also, so I think there are 3 different devices, or one device, different sensors.
So it's one device. We can even have more sensors in one device that can sense several parameters. But this particular is just one device that is going to sense those 2. We're just starting along the line. You can incorporate more sensors. What we mean sensor, we mean sensor for ozone is incorporated into the device. Sensor for nitrogen dioxide is incorporated. Sensor we want to do particulates and incorporated. So the different sensors, we can have 5, 6 sensors in one device. No questions.
So, any other questions? Okay. I'm here with director. She's here. Ready.
The sensor is it going to improve the particulate matter? And that's one question. Then the calibration. Since we are connecting it with here in Africa, which standards are we looking at? These are the things we must agree upon, even though we have a global or WHO standard. So, but we should also note that in our things, another standard sure, so that it can be more united and constant.
Thank you. I want to appreciate Professor Biake, Robert Biake. Thank you for coming. The standards, that's why we're working with the policy makers. So we're working with governments. We don't have standards. We've been doing the air quality issue, collecting of data and so on. It's just coming up in Africa, in the global south. Like you saw the map I showed you. We've not gone far yet. So we have to set our own standard. But for now, for the meantime, we will just be working with what is available. The WHO and the USDPA for now, until we're able to set our own. We cannot set our own standard until we have enough data. We have to collect enough data to be able to bring out something that will help us to set our standard. And this is the way to go. This is how we're starting. You asked whether this particular device has PMs. No, we're not looking at PMs in this case. Already we have some PM devices, and it's been much more difficult to have gaseous monitors because of the stability is really difficult for the manufacturers to handle. So that's why it's difficult. So what we're doing is a difficult thing that we're trying to do, problem we're trying to solve. So we start gradually.
So just gases, no PM. We already have a PM, enough PM being installed. Now because I think you have 28 sensors already, so we have very well to go. Yeah, we install sensors on the disease. So I'm happy that Ms. Osho is here. She's one of the drivers for ASEPA. So any other question? Oh, no, any other question? Oh, okay. So let's just move on. So let's have the next speaker. So we have the next speaker. That's also Ismail Ibrahim, the Afretech coordinator. Good afternoon, Prof. Are you online? Okay, so let's just go on. Let's have Mrs. Colin Bagwai, Lucelis. You can actually share your slide and go on with the presentation. Thank you.
Hi, everyone. Sorry, we are having a bit of a hard time online. It's a little muffled. We can hear some parts of it. So, apologies if we are missing some aspects online. But in any case, I hope I heard it right that it is my turn to present. Okay. One moment. I'm hoping you are seeing my shared screen right now.
Yes.
Okay, thank you so much. So thank you, everyone. I can see that it's a full room there in Lagos, and also online. It's a full house. So thank you so much all for your time today, and I really appreciate the invitation from Afretech and Professor Rose Alani. So I'm very excited to share with you about OpenAQ and the work that OpenAQ can help you with in terms of air quality monitoring and sharing your data online. So I've introduced myself a while ago, but I'll introduce myself again. I'm Colleen Rosales. I'm the Strategic Partnerships Director at OpenAQ. OpenAQ is a US-based nonprofit organization, but we serve worldwide. So we host data online, and I'll show you a little bit about our platform. So our team is a small but mighty team of 3 wrangling the world's air quality data in an open source platform. Our goal is to provide universal access to air quality data so that global change makers like yourself can work to solve air inequality. Like I mentioned, we are a nonprofit organization based in the US, but we serve worldwide. And we were founded in 2015 by Krista Hazenkopf and Joe Flasher, uh, where we initially ingested and aggregated reference monitors. But as Professor Rose Alani mentioned a while ago, with the rise in air sensors and sometimes they're termed low-cost sensors, but they're definitely not low cost all the time. But with the rise in the use of these smaller sensors, there's more um, coverage nowadays, and it allows a lot more countries and a lot more cities to measure their air quality. So now we also ingest air sensors as well. So if you want to learn more about OpenAQ and its origin story, the short link is here below. So our goal and our purpose in the air quality space is to aggregate all of the data in a one-stop shop platform so that you don't have to wrangle the data yourselves and you don't have to spend all this effort and time into the nitty-gritty and tedious work. And so we would like to make your job easier in terms of transforming data to action or data to information. So this figure here shows, kind of where we sit in the air quality ecosystem, where we serve as this universal data sharing platform for air quality data. So the OpenEQ platform, like I mentioned, it's a platform that is open source and that is something that you can access without cost. It is free to use, and it also has a lot of tools that can be used by researchers like yourself. So we are aggregating data from all over the world, and as has been alluded to a while ago by South. And so we are here to support, say, for example, you're planning to put up reference monitors or air sensors and want to put that up in a public platform. We're happy to help you with that. And I'll talk a little bit more about that later. So in terms of the other end of the spectrum, where if you're the one who will be a user, rather than putting up the reference monitors or sensors, we can also help you with that. You can access the data in OpenAQ, again, for free. There's no charge to download or access this data. And we focus on criteria pollutants as listed below and here. I guess I've been mentioning that we are aggregating both reference monitors and air sensors. So we present this in different products. One is the API, which is a more programmatic and real-time access. And so for example, you can build apps or you can build a website on top of the API. For research or bulk or historical downloads, or say, for example, you're generating a report, you may want to look at long-term trends and you can use the archive for that. And then also what I will do a little bit of walkthrough today is the Explorer, which is the more intuitive, and it has a graphical user interface where one can view it on a map and use the search bar to search for countries. We also release a lot of other tools that are more programmatic in nature, such as the command line interface and the Python wrapper. So I won't really talk much about the API today, but I know there are certain audience that are more inclined to access the data more programmatically, and so we have a lot of documentation and resources and recipes that are available online for API access. And so if you are interested to learn more about that, here are the links for that, and feel free to take a screen cap. And I know this meeting is recorded, so these will be, I'm happy to send out these links to you as well after the meeting. So back to OpenAQ and who do we serve. Uh, Again, the main purpose for all of us working in the air quality space is to improve the air quality, and we play this role in data management and data engineering to help you, make those actions and make those policy recommendations and actions to better our air quality. And so we can do that many different ways. And so just listed some in here, in some of the user base that have used OpenAQ in the past. So, and present and in the future. In the past, majority of the users of OpenAQ has been scientific researchers and analysts, but we've been continuously creating tools such that we can enable a larger user base who are not maybe not on the scientific end, but if their use case is on advocacy or policy making, we're hoping that the tools that we develop are also going to be useful. So I'll kind of run through some of the use cases, and I hope that some of these will inspire you and also kind of enable you to see where we can fit in your work. So some fun and educational examples here are one, the Smoky Air Pollution Bot, which is a chat bot that you chat with in Messenger or WhatsApp, and then you ask it what's the air quality outside, and it will give you the levels of pollution outside, as well as what can you do to protect yourself from, if say for example the levels of the air outside is hazardous. There's also another fun app called Shoot I Smoke, which equates the equivalent number of cigarette smoke compared to the level of PM 2.5 that is there outside. So even if you're not smoking, effectively you might be still breathing in this similar level of pollution as if you were smoking a cigarette. So those are just some awareness apps that have been built on top of OpenAQ. So we don't operate any of these apps, but they use the data in OpenAQ to inform their apps. So other use cases for OpenAQ. So Clean Air Catalyst is a USAID funded project. It is run by the World Resources Institute and Environmental Defense Fund. And the goal is to put up reference monitors in Indore, India, Jakarta, Indonesia, and Nairobi, Kenya. And so our role here is to support data management for these cities so that they put up their reference monitor, they put their data on OpenAQ, and it's going to be available in a public platform. We also are used in Bloomberg Green's PM 2.5 tracker, which shows the population and pollution levels. And by these information, they're able to show which countries or which locations in the world are highly affected by air pollution. So that's an example of evidence-based journalism. So many different use cases and perspectives, and how air quality data can be used. A very new set of sites that is currently available on OpenAQ is Peru's reference monitoring station. So we worked with the organization in Peru, a government organization in Peru, to be able to put up their data on OpenAQ. So now these are government level reference monitors for PM 2.5 and PM 10 that are freely available in OpenAQ. So some more uses in terms of machine learning. Now that's such a buzzword, and so these are just some examples of use cases that do use machine learning and the data in OpenAQ as something to feed into these machine learning algorithms. So say for example, AQAI is a UNICEF venture fund backed organization that aims to have predictive models for locations where there is little to no air quality monitoring. There's also predicting what we breathe, which is a project of the city of Los Angeles here in the US. And in collaboration with the university, they were able to build predictive models for the city of LA that can do air quality forecasting up to 10 days at a time. And so again, these are, we don't do any of these research ourselves, and we also don't collect the data ourselves, but we do provide these data so that other people can, do great work with the air quality data that there is worldwide. So I just wanted to put out also, we wrote a report in 2022 about the survey of the global landscape of air quality monitoring all over the world. So here we surveyed all of the countries and looked at which of these countries do monitor air quality, which ones share their air quality data, and which ones don't share their air quality data. And so if you're interested to learn more about that report, the short links are here, and we're also gonna put out a report very soon. So yeah, do watch out for that. And so I do want to take some time to walk you through, our Explorer and where Explorer sits in this, data science hierarchy of needs, is somewhere in the data visualization part where, data analysis and characterization are enabled by the use of these data visualization tools. So initially, we sat here in the data engineering management, kind of bottom of that pyramid. But now with much of these tools that we are developing, more and more use cases are available for the air quality data that is in OpenAQ. So, just a little bit of walkthrough. If you haven't been in the Explorer OpenAQ website before, this is how it looks. There's a map, there's that search bar that you can search any location, and then you'll see that list of pollutants that is hosted on OpenAQ. Again, what's important to note is none of these data belongs to us. This data belongs to whoever measured that data or whoever is reporting that data. And that license or that ownership remains to be theirs. And so, again, we host reference monitor and air sensor locations, and you're also able to access real-time and historical air quality data. So this is an option here that allows you to do that. And then you can also choose different data providers. So like I mentioned, we're an aggregator. And so we collect all of these air quality data that is already put out there by these providers into a one-stop shop. So say, for example, a reference monitor in Abuja is existing and has public air quality data. And then also an air sensor in Lagos is measuring air quality data. And so we aggregate all of these in a one-stop shop platform. And so just some examples of some locations that are available, just so you can see also the sidebar here. So once you choose a location, say for example, this is a location in Thailand, it shows you what the air sensor type is, what is being measured in that location, who is the source or the air sensor provider, when was the last reported measurement, and then what are those measurements that were reported. So this is one, or actually two, sensors that are located in Calabar that is put up by our OpenAQ ambassador, Teresa, out of Calabar. And so she was an ambassador for the year 2023, and their cohort graduated in March of this year. So those sensors are still up in Calabar and I think Obubra. So yeah, if you're interested, do check that out, and I'm happy to connect you with Teresa as well. Another sensor that, or sorry, air monitor or reference monitor, excuse me, that is available currently for Nigeria. One is in Abuja. So this is a reference monitor that is provided by the US Air Now provider. And you see there that PM 2.5 is the pollutant that is being reported there. So actually, let me move back a little bit. So if you click on show details, so it's not just this, simple spark lines that you can view on there, but if you click on show details, it will actually bring you to a page that will allow you to view these plots. And these plots you can view without having to sign up for an account. It's in there, and you're welcome to view these plots right away. This will show you the latest readings, the time series, which are here on the left, and then some patterns like diurnals that are available for whichever pollutant that you choose. So that's kind of the sort of detail that you can view on OpenAQ. So that's the image on the right just shows you that whole detail page. And then there's also an option to download a CSV file if you wanted to generate plots yourself, if you wanted to, analyze this data on your own in a programming language or a software of your choice. So in some instances, or in some of the features of OpenAQ, an account is required. So say, for example, for the download, you do need an account. But an account is free, and minimal information is required. So you still get your data for free. So one very new feature that we released recently is the custom lists or the lists. And this allows you to create a list of locations that you are interested in, or say, for example, you're an air quality manager that manages a whole fleet of sensors and monitors, and you want to see them all in one location. So say, for example, this is synonymous to a bookmarks list in your web browser or a favorites list in your web browser. That's the same idea where you have your favorites or your interested locations in a list, and then you can see them all in that one list that you created. So yeah, we hope that's one of the use cases that you will be interested in. And say, for example, again, if you are someone who is managing, many different types of air sensors that are manufactured by different companies, and then a reference monitor that is from a different provider, you don't have to go through each one of these different dashboards or different websites. You can see them all in OpenAQ and download the data from one location. So, saves you time. So I just wanted to highlight, I mentioned to you Teresa a while ago, who is one of our community ambassadors. Another community ambassador that we have from Africa is Malkia from Nairobi. And both of them, this whole cohort graduated in March of this year. And then we started a new cohort just last month. And again, we have two ambassadors from Africa. So Melissa from Cameroon and Antonio from Mozambique. So if you're interested in connecting with any one of them, please do let me know, and I'm happy to connect you with them. So with that, I'd like to stop there and entertain any questions. Again, if you're interested in either being a user of the data in OpenAQ, or if you're interested in putting up reference monitors or air sensors and want to make that data public, do let us know. Get in touch with us. Our information is here on your screen right now. And also, I'm happy to kind of brainstorm how we can, make your data public, or, give some trainings about the Explorer or the API. We're also happy to facilitate that. Thank you so much.
So I think she has done a great job trying to enlighten us on what is available. So just quickly have the question and answer. So the first person says, please, I'm interested. Definitely you will, because even though you don't eat, you want break there. So definitely you will. So how can generative AI be used on AQ data for descriptive, predictive analysis for cleaner for all? I think the next presenter will talk about this. So just kindly hold on for the next presenter. He says, how can we leverage advanced technology like AI, IoT, Internet of Things, and satellite imaging to enhance the accuracy, spatial coverage? I think Dr. Rosalis, you can answer this, please.
Sorry, it was a little muffled on my end there.
Okay, can you hear me now?
Yeah, I can hear you better now. Thank you so much.
Oh, okay. So the question is, how can we leverage advanced technologies like the AI, Internet of Things, and satellite imaging to enhance the accuracy, spatial coverage, and the real-time availability of air quality data, and what are the potential applications of such innovations?
Yeah, thank you so much for that question. And I see it in the chat now. This is a question that encompasses many applications and also many technologies. So I'm hoping that at least the data in OpenAQ can inform AI. So like the example use cases that I mentioned a while ago for the city of LA and AQAI, they are using the data in OpenAQ to inform their models. And then also, I think, if you're able to build some software or chatbots, like the example that I gave a while ago, that is something that, can call the data from OpenAQ to inform the chatbot. That's awesome too. And then also for areas that are, there is little information on air quality data, models can hopefully help supplement that. There's also satellite data that can help, with so nowadays there's techniques that do data fusion for point sources and ground data, like the ones that are in OpenAQ, as well as satellite data. And so this provides a complete picture, or hopefully closer to complete picture, of the air quality levels in locations where there is little to no air quality data. And so in terms of IoT, I believe there is a lot of small sensor related air quality monitors and sensors that are being built not just on a manufacturer level but also on a DIY basis, where you can find a lot of open hardware kind of templates and recipes online on how to build your own air sensors. And so they're becoming more and more accessible nowadays. And so I know, say, for example, Sensors Africa has these sort of information. And so there's a lot of material nowadays that can really leverage IoT and the DIY nature of air sensor. So yeah, there's this whole spectrum of air monitoring that we can do, from the reference monitor, which is super expensive and super accurate, up to the more cost effective, but also you need to put in more work on your end to create this own sensors. So yeah, really there's a lot of technology nowadays that can enable air quality sensing, and putting the data on a platform that is available for folks to use. So yeah.
Okay, so thank you. So before we proceed to the next question, let's kindly have I think let's make welcome the MD of LASEPA. Yeah, the GM LASEPA, Dr. Tuja Jai. Oga, the top, please, can you just unmute, and we just want to have a word from you. Sorry that we took so long to recognize you on the Zoom platform.
Okay.
Okay, I think when you return, yeah, he has been there. So whenever you return, so just make a welcome. So let's have the last question. The last question for Dr. Khalid Rizali. We have one more question. He says, I am interested because I'm monitoring data using the air quality sensors, but I cannot really get detailed data. I think that's why the open AQ data is available for you, and a link has been created because of our time. So we'll just move on to the next presenter. So okay, okay. So Dr. Rosalia, question for you.
Okay, thank you so much for that presentation. You said something about the reference monitor in Abuja. Do you have the data there in OpenAQ? And if you have, it's not so easy for everybody to access the reference monitor and go and co-locate there and collect data and then calibrate with our low-cost sensors. So it means if you have the data from the reference monitor in Abuja, and you said we can, look at any period we want, it means we can we co-locate or locate our local sensor somewhere not too far away from there, and then rely on getting the data from OpenAQ to co-locate or to calibrate and be able to get a factor to get a local sensor data accurate. So can you supply such data to us so we don't need to write for permissions to go to US Embassy to co-locate?
Yes, thank you so much for that question. I think it was Professor Rose. And yes, the short answer is yes, you can access data from the reference monitor in Abuja. So here is a live link. I'm hoping that you can see the shared screen right now. Here is the Explorer website, and I think this is the location you're speaking of. So if you click on show details, you'll see information about that site. And since when it was reporting to OpenAQ, or since when we are gathering that data. So you'll see here the availability is since 2021. There have been older locations, maybe in different countries, that can date up to 2016. So I think the one in Addis, we have data since 2016. So it just kind of depends on either when they started reporting to OpenAQ or since we started ingesting that data. So say, for example, this one, the plots here, the live plots are only up to 30 days, but you are able to access the historical data up to 2021, either in the API or if I scroll down here, sorry, it's a little small, I'll increase the size. So you can select the start and end date here. So if you select maybe 2021 or something, if you wanted to access older data, you can do so here. And then again, an account is required to download the CSV data. And then you'll see here some plots. So again, like I mentioned, the years that are here are 2021, 2022, 2023, and 2024. And so you're able to, I'm not sure why there are drawings all over there, but so you can see the median, the percentile, etc. Again, this is just the live plots, but you are able to download these CSV files on your end. And then say, for example, actually, there's one other thing that I wanted to show. You mentioned, co-locations, and then also, how you can co-locate your air sensor data and wanting to place that near, say, for example, this certain location in Abuja. So let me pull up an example of a feature in the lists where you're able to do the planning needed for this co-location. So sorry, I'm gonna move forward here. So say, for example, over here, you can see, you add these locations to a list. and then they'll be yellow. And then if you move forward, you'll see locations that are in gray. And so spatially, you can see where all of these monitors or sensors are. And then you can plan, okay, I want to co-locate. And then that means, I should probably place it close to a location that I have marked, something like that. So yeah, those are just some tools that we have, and I'm happy to talk more about that in a more specific manner, specific to your project. So yeah.
Thank you. We are grateful with that particular information. So,
So thank you, Colin. You mentioned Sensor.Africa that helps, in building sensors. If we have any need for that, Sensor.Africa is also online.
okay, so I think thank you, Ms. Rosales, thank you. Let's just move because of our time. We're speaking on harnessing language models for enhanced air quality and climate data accessibility and analysis. So we have Dr. Davis, Brain, Segera. Hello, doctor. Hello. Hello, can you hear me? Dr. Davis. Okay. Okay, you can proceed with your presentation. Thank you.
No.
Dr. David, you can go on with your presentation, please. Okay. You can see your slide now, so you can go.
So you can hear me now?
Yeah.
Sorry for that. Sorry for that. Yes. So yes, I'm from AI, and I wanted to talk about large language models for enhanced air quality, data accessibility, and analysis. And I'm so happy for what Colleen Rosales has talked about, that we have a bank of data that we can harness through large language models. I had somebody ask, how can we leverage on generative AI so that we can benefit from this? So that is the talk that I have today. Yes, so the air quality and climate challenges, the current state is that, of course, people use ground-based sensors and satellite observations to track that. And then, of course, we have monitoring temperature, precipitations, and all this using satellite data. The challenge we have is there are data gaps. Even from the maps that Colleen Rosales displayed, you could see that not all the areas are covered. Like in Africa, quite a number of countries have not been covered and reported in that OpenAQ platform. Then, of course, we have data inconsistencies in terms of variations in sensor technologies, discrepancies between satellite and ground data. Then, of course, we have accessibility issues, limited real-time data access, but I'm so happy that OpenAQ is trying to promote this. So what is the importance of reliable data? Out of reliable data, then we have better informed decision-making processes, which are essential for our health, impact assessments, urban planning, public health, and all this. Then, of course, it supports rapid response to pollution incidents and extreme weather events. It informs policy and also public awareness and engagement. So artificial intelligence, what are the capabilities and key applications? AI simulates the human intelligence processes, like machine learning, of course, identifies patterns, makes decisions. Natural language processes understands and generates human language. We have computer vision, which can interpret visual inputs, and they are very key in predictive modeling, anomaly detection, data integration. So how can we adopt AI in environmental science? It can help us for automation of data collection. You can have AI-powered sensors and drones that gather data autonomously. You can have satellite images analysis for continuous monitoring. Then you can have automation of data analysis. You see, like we had the AQAI platform that Colleen Rosales talked about. So of late, I'm very, very keen on large language models. And one of the top in the list is GPT-4 that has been trained over 1 trillion kind of parameters. So you can imagine how powerful it is. And somebody asked, how can we use this kind of tools so that we can leverage on the bank of data from OpenAQ? And Colleen talked about their API that is free. So it's now you develop a layer of large language models on top of that, and it can be like an advisory tool. It can also be an alarm tool, depending on the kind of emissions that you have. So we can use them for data integration and harmonization. And then we can use them to create a unified data set. One thing that I've been trying to do is employ also, rather than the sensors only, we can have the cameras closer to the sensors so that we can have metadata, which can be more informative in terms of the pollution that we have, because we have an activity, like a photo of the activity associated with the pollution in it. So if we can have this, then we can leverage large language models for this kind of process. I'm sure people have interacted with, for example, ChatGPT and all this. They are user-friendly. You just give a query, you get a response. And depending on the prompt that you give, then you can get more informative information from them. When we talk about automated analysis, we can use LLMs to analyze very large data sets, like the ones OpenAQ are putting together, so that we can be able to identify trends, patterns, and anomalies. We can also be able to detect changes over time. For example, rather than going to their website and checking, if we have a chatbot that is already linked to OpenAQ through the API, we can be able to detect those changes real time. Then, of course, we can get better insights and reports. when we have such kind of combinations. There are some success stories, for example, in Beijing, China, where they have deployed an LLM to integrate data from ground-based sensors, satellite imagery, and social media reports. And the outcome is that you have improved accuracy of air quality predictions. You can also identify the pollution sources, and then you have enhanced public awareness, better decision-making, and for control measures. In the United States as well, we have the EPA that has used an LLM to harmonize data from various regional monitoring stations and satellites, a similar case to what OpenAQ has done. And then we have a unified national air quality database, a development of predictive models. And then we have a kind of informed policy making and all that. Okay, what about climate change? Also, EU researchers have used LLM to analyze historical climate data, scientific literature, and model projections. And we have now a detailed climate impact reports, enhanced understanding. We have also weather forecasting and disaster preparedness in Japan as well. So this, you can see that Africa is not featuring, and that's why we have this kind of talk. Like, how can we now also become the key? Can we become the players? If we are not the key players, can we become the players in this? The players in this. So the challenge is probably before we consider full-fledged LLMs is that there's a lot of noise in the data collected due to, for example, sensor malfunctions, environmental interference, human errors. So these data gaps also, we have data gaps when they create data gaps when the sensors fail, then the real-time data collection is interrupted. And then we have incomplete geographical coverage from the maps, you could see that. So how can we use LLMs to mitigate through this? We can use them to identify, to filter out the noisy sensors from feeding into the dataset. We can also try to use LLMs to predict missing values by analyzing patterns and correlations in the available data. We can use them for standardizing the data as well, but the limitations are that LLMs can still struggle with highly noisy data. So if you have so many malfunction, the kind of sensors, there's a lot of human interference, then that data might not be useful. Predicting missing data is not always accurate, especially if there is insufficient, of course, contextual information. Standardization efforts may not also fully resolve these kind of fundamental inconsistencies in data collection and methodologies. And also, you have been hearing about ethical and privacy concerns. Yeah, that's another kind of challenge that dealing with LLMs or deploying LLMs come into place. There is also a lot of computational demands that are required. You can imagine like the servers of the ChatGPT, how powerful and big they are and costly they are. So we are even now in the process of developing more powerful GPUs, which can be able to accelerate or give the computing resources that are needed. But in future, all this will be possible. So the future directions is that the model size and complexity, of course, it will be enhanced to understand and generate complex languages. They will be multimodal. In other words, they will integrate data from text, images, and sensors. Then we have efficiency improvements due to reduced computational resources. And what will be, when we do all this, what will be the implication on air quality and climate data? Then, of course, we will have enhanced data integration, real-time analysis, personalized insights. Then, of course, it is important then for us, AI researchers and environmental scientists, to come up and develop specialized models. This is the time. This is the time we should grow as the AI tools grow. The policymakers and stakeholders should also not be left behind because we need them to align technology with their policy goals. And then we can work on projects like Project AI View, where AI-powered airport monitoring tools can be deployed in cities. There's Climate AI Initiative for predicting climate impacts, change impacts. Yeah, so there is also the concept of funding. So this kind of work needs some support research, initiatives and partners. We also need to have regulatory frameworks in place. Then the global collaboration, and I can see Colleen Rosales is really pushing that so that we have all this in place. So thank you so much. Sorry, I had a hiccup in the beginning, but here I am. Thank you.
Yeah, thank you, Doc, for that. Let us go straight to question and answer. Thank you, Dr. David. So, any question and answer from the audience, online participants? Online?
No question.
Okay. Okay, I don't know how this question is directed to Dr. David. I think it's three. Okay. So the first for the online participants or question, so it says, how do we ensure the security of the data? What are the ethical considerations that should be observed during the data collection?
Oh, is it directed to me? Can I respond?
Yes, please. Yes, please.
Yeah. So it's a big concern with the AI, the kind of direction that I'm seeing many companies and many AI frontiers are taking place, or the following is that there is normally a mutual agreement between the provider of the data and the developers of large language models or machine learning tools. So there must be mutual agreement in this. Like, what are you going to do with the data? How safe it is? For example, if I can talk about the GitHub Copilot that we normally use. I'm a programmer myself. I normally use it a lot to code. There is a clause there that the code that I generate is not shared with the other people, with the other kind of programmers in the world. So that's the kind of privacy large language models, developers or machine learning models that they are taking. So there is the mutual agreement between the users and the developers, or the providers of the data and the developers. Yeah. So we cannot, like, they cannot just come and pick your data and they use it. No. So there is an agreement.
Okay, thank you, Dr. David, for that question, for that answer. So for the audience, can we have any question from the email? Any question? Any question? All right, thank you, Dr. David, for that wonderful presentation. No more questions, so we can just move to the next presenter of the day. So the next presenter will also talk about linking air pollution and climate risk. That will be taken by our able Mrs. Titilope Akosa. So she's in-house, so she will be presenting via Zoom. So no, come.
Yeah, I hope you can hear me. Yeah, good afternoon, everyone. Yeah, I'm really sorry that I'm not projecting the PowerPoint, but yeah. as you have heard from the last speaker, we saw the lot around how getting climate data, improving the air quality data, and how all of these things work together for us to have an important evidence of what is happening in the environment in terms of the quality of air, climate impact, and how this data can be also used, of course, for different stakeholders. There are different analyses for different stakeholders that we have had. So then we asked ourselves, what is the linkage between air quality and climate change? And if you have had, I don't want to tell you again what is air quality. I'm sure we have what has been explained here. But for us, also, we know that climate change is happening, and we know it's a long-term change. Yeah, the weather around us, a lot of us have been hearing about climate change. And what are the impacts? What are the things that causes climate risk? I think I'll just need to read from what I have. The risk is generally defined as a combination of likelihood of an occurrence and the consequences of that occurrence in practice. Neither likelihoods nor consequences are known. Neither likelihoods nor consequences are known with certainty. So that is a part of climate risk. And climate risk refers to assessment based on formal analysis of the consequences, likelihoods, and responses to the impacts of climate change, and how societal constraints shape adaptation options. So, climate-related risks are created by a range of hazards. Some of them are slow in their onset, such as changes in temperature and precipitation leading to droughts or agricultural losses, while others happen more suddenly, such as tropical storms and floods. So we are talking about climate risk here. And what are the elements of climate risk? We have probability measures, how frequently an event is likely to occur. We have the second one, exposure, and then we have consequences, which leads to full or partial damage, injuries, or loss of application. Then, how can air quality influence climate risk? This is very, very important. That's where the linkages here is being connected. So, for instance, one of the impacts of climate change is rising temperature, which we all are aware of. And then, climate change contributes to global warming, leading to increased temperature worldwide. The higher temperatures can exacerbate air pollution and impact air quality, posing health risks to population. Do we see that? So once we have that high temperature that is induced by climate change, it can also affect our air quality. Okay? Increased extreme weather events also happens around us. Climate change intensifies extreme weather events such as hurricanes. We don't have those kinds of things here, what happens in other places. Also, we look at heat waves and other impacts. These events can worsen air quality by releasing pollutants into the atmosphere. We have seen that at times when you are flooding, all these extreme weather events can release pollutants into the air. And these are some of these pollutants that the open data people are trying to capture for us, and also tell us how much our air is polluted with all this they are monitoring sensors. So we have carbon pollution also. We all know what carbon is, and we all know that carbon is the main culprit that is driving climate change impacts. So everyone is saying we must reduce our emissions. So what are the sources? There are different sources of carbon emission. Industry is there, energy intensity is there. I'm coming. Transportation emission. We're here in Yamata, you said something about that this morning, and our vehicles and some of the different sources from which we can have carbon. So once this is released into the air, we all know what carbon does when it comes in terms of climate change. It drives climate change. And that's why most of the time we are looking for carbon sinks. We are looking to plant trees to sink carbon so that it will move from the air. So when these things are removed, of course, it can pollute our air, and some of this pollution also can be captured by those sensors that have been, I think, placed all around Lagos right now. And I'm sure that there are still so many sensors that is coming into Lagos, if I'm correct. It's from what I heard here. Yeah, and then, of course, we know about health impacts of poor air quality also. Some of these things happen from the impacts of climate change. And then environmental degradation too also can influence the air quality around us. If our environment is degraded, waste is all about, and there's, of course, there's this methane that comes into the atmosphere through waste. And we know we have a lot of waste in Lagos. And I'm sure that we understand also this waste also with our environment. And we also know that methane is even much more dangerous than carbon dioxide that is driving climate change. So that is our driving climate change. And see how we all connect to air quality issues that we are dealing with. So there's no way that you're going to be dealing with air quality that will not also actually deal with the issue of climate change. And I think I'm so happy with the open data information that we have had today. Most of the data they are capturing, they're capturing their particulate matter the way they're capturing that. And I think from the last presentation, they're also capturing climate data also. And I believe that in Lagos State, we can also ensure that as much as we are capturing air quality data, we should also be able to capture climate change data so that we can have a holistic way of addressing some of these issues. It will help us look at how poor our environment is in terms of air quality. It can also help us to address the impacts of climate change. And it also can help, I think, plans. It helps us to plan ahead for some of these disasters. And then we also understand what is even happening in our environment. And more importantly for us, we must also begin to think how do we understand how all of these things connect with health outcomes. That is very, very important. Yes, we have started capturing data, air quality data. We have also started doing a lot also around climate change. And now, how does health come into the whole of this? Because today we can say the quality of the air in our environment is poor. Yes, we can look at some of this data, but how do we link this data to health outcomes? What is happening in our public health institutions? What is happening as we look at our public health records to substantiate that this poor air quality is causing some diseases that we can find in our environment. And this is another aspect of this air quality issue that we need to factor in as we continue to gather the relevant evidence. Yeah, I'm almost through the relevant evidence. Then, of course, urbanization challenges. We know every day we are building one thing or the other. Every day, of course, today we are building our Calabar coastal road from Lagos to Calabar. There are so many things happening, industry setting up and things like that. Of course, when these things happen, whether you like it or not, our health will be okay. And it depends on how we address these issues with the data we are capturing and the kind of intervention we are putting in place. So, what is most important here is that all this data needs to put some human face to them. Some of us are not scientists, some of us are not interpret some of this data, but I know that if this data is interpreted in such a way that all of us understand things, it will make a lot of meaning to us, and we'll be able to do a lot of advocacy and explanation at community level. And it's also very important that community are aware that these sensors are being placed. How do we build community, what they call community monitoring spaces around this air quality sensors, so that community will understand that these sensors are there, it is our own, we want to own it, we want to protect it, and we also want to understand the kind of data that is coming out from it, and then how do we use it also to do a lot of advocacy, and especially doing a lot of advocacy and around rights to breathing. This is very, very important for us. I know a lot of community people are here, and these are some of the things you want to hear. These are some of the things we want to do. So how do we address this air quality issues and climate change together? Of course, for climate change, we need to start thinking about switching to cleaner energy. Yeah, and that is the future now. Nobody's looking at dirty energy anymore. People are trying to divest from coal. People are trying to divest from even fossil fuel that is the mainstay of our economy. But I know for us in Nigeria, it will take us some time. But yes, we will take our time to divest from it. Yeah, I quite understand that. So, but for us, the little ones that we can start doing from our homes is very, very important in trying to switch to cleaner energy. And then how do we deal with our waste disposal, reduce, and all those R's that we normally talk about? Of course, when we are also doing all this waste recycling, we must also be very careful that some of this is not everything that's recycling. We must understand that. And I remember when we have a project called the Next Seven Project with communities in Lagos. So we found out that in some communities we are trying to do what are called waste recycling, and then all of a sudden there's a whole lot of going out into the community, causing respiratory diseases. So of course we are trying to deal with the thing. We are trying to do use to sample and everything. But at the end of the day, it is causing another unintended health risk to our population. So that's why we need also policy. We need policy to regulate these things. Also, we need research to understand the impact of some of the things that we do. Because at the end of the day, whoever is trying to do recycling, setting up an industry, a recycle industry, wants to remove what they call methane, if I'm correct, from the landfills, wants to ensure that we also maximize the use of products rather than just throwing things around and some of these things stay long in the landfills and things like that. We are trying to address the impacts of climate change. But at the same time, if what you are trying to do is also causing another problem rather than causing air pollution and also leading to health risk and health issues, these are areas in which research is needed. We need to do deep research to some of these things that are happening. We need to understand the impact of some of the solutions, climate solutions that we are putting in place, and to see whether these climate solutions actually are not causing new problems that we may not be able to deal with. So I think for us here today, it's very important we understand how these things interconnect, what kind of interventions we can do as a community, the kind of intervention government can take, and the kind of policy that government can put on the table. These are the most important things. Thank you very much.
So really quick because I don't like wasting time. My 1 hour is 1 hour, so let's try 1 minute. So any good question? Any good question? One. Okay.
Sure. I think with the very critical.
Hello.
Yeah, I think I would say too critical. Said so much. I understand all this, but I think what why is it that the global north, young people are suffering plus climate issue, whether it's hurricane, we don't have that. All we have is floods. Where are we going to this? I know we are talking here about urban transport. Climate change. Don't you think that? Well, I think that the global north has what's the leaders. We all agree that what's the leaders of all these decisions. Yeah, not us, because they have the industry, they have this, and they set standards over there. For us, it's not everything that should be directed. So maybe we can cut that and find our own and you know, sometimes the greatest cause are global. That's why I saw that graphic, I saw this category, I saw the body, I saw this. That's the reason why. Most of them are profits, but those are far less when you look at China. Small to well, small to well. I'm not saying that we're not doing things we have to mitigate. I can't speak much of other sectors. I mean, I'm concentrating on transport. I just want us to have a general perspective about that.
So, let's one. Okay.
Yes, I think that's a question. Because you keep talking about the digital standards. I think we need our own.
That's why we can't say
No, I'm not saying that.
Yes, but because of that way, we can't ignore what's that. We can't stay alone because we find something in terms of air pollution. We have the secondary source and we have the resource. And so they can be polluting and might not affect them. It might be because of the weather condition and the meteorology of how the world is all around. So that's why everybody has to work in a team, in a collaboration, so that the effects will not be years to come. I say, oh, let us ignore it. Years to come, the effect might land on our own climate, on our own land. So because of the nature of what we are weather condition, we can say, oh, we are stable, but we can't know in future. And that's why we need to still hold on together as team and work and make sure we work on our own effects now, so that in the future, and they're also working on their own, and the world will be a better place.
Okay.
Okay, one more.
Yes, yeah, I think
No, your voice is already went up.
okay, I think what he said is right. But another aspect of it, they protect themselves. They absorb the effects of their emissions more than we do. So they have so many sensors. And then, for instance, carbon monoxide. We do not know how much of it is in the air that we breathe here. But over there, most houses have carbon monoxide monitors. So it gets to a particular level, we know it's dangerous, and something is done about it. Unlike here, no matter what we produce or emit in terms of carbon monoxide, for instance, we do not even know it. And then carbon monoxide can be high in your bed, and you do not know. People can sleep and not wake up, and nobody knows what was responsible. So that is the basic difference. They are more exposed, and they are also more protected. Thank you.
We don't have enough data to tell the facts.
We do, because those of the PhD students are already working on such projects.
I think they should have been part of this workshop.
No, they are here. Yeah, all this line, they are the ones.
No, she's not.
They are the ones. No. It's their pages.
So let's proceed, please. One
Mama, I need to have something to say. Or should I just go on? Oh.
Thank you, sir. And I'm trying to respond to what you said. So, yes, it's true. You know, they are already developed, and we are developing. So, what they have passed through, we are coming up to pass through that also. The amount of emissions from vehicular sources they used to have, we are also coming up.
We're very guilty about that.
So, in every aspect, industrially, we are also coming up. In everything, in population, urban population, all these we are also coming up. So, what they're doing, like you rightly say, they are monitoring. Like you said, monitoring, they will know what the problem is. Then this is what we are trying to do. So when we monitor, we'll be able to know where we have issues and how to control. Like they are also controlling. And we cannot do it alone. They are already experienced with this. That's why in our work we carry them along. We learn also from them. So we're not going to use exactly what they we also have our own initiatives, our own minds that will take it into our situation and see what works for us. So we work together. And so that is it.
Thank you.
So let's just go. So the next one we have it that's the challenges we have it two in one. So we have Mr. Kyrie is all coming to tell us. Yes. Yeah, so it's that on.
So just make this quick because I know most of us are already tired. So we don't need to start projecting, start naming up. Basically, Dr. David has said what the challenge is. One of them is limited air quality monitoring. That's why we don't have air quality monitors. And the second one, data gaps. You understand? Lack of data, inconsistent data. And also, that's basically the two things we are dealing with at the moment. Now, I don't know if Dr. Davis is still online. I'll maybe I want to contribute. Yeah, sure. Okay. So, I don't know if Dr. Davis is still online. I would like to ask. So, for the open AQ, if you can go to the site to access data, how can you verify if the data is reliable? I might use a local sensor now and just upload the data. It might not the equipment might not be calibrated. And all of a sudden, they're putting it there. You understand? So if another person just goes into the pool of data and uses it, how does it, how can you verify the reliability of the data? Okay.
Yes, thank you very much. And thank you everyone for attending this workshop. With regards to our issues, yes, it is obvious. We are all, victims of this greenhouse gas emission. Particularly with, it's not just, from transportation, and even we using the generators at home. And then there's just recently, about 2 days ago, we had a Lagos transport policy that is now law. And then it addresses a lot of all these things as well, the greenhouse gas emission. Well, I also want us to also, the freight, cargo, because especially when this is freight from the vehicle movement, they go through all that and they produce. And I think personally, this is my own opinion, the freight contributes way more than public transportation and private vehicles. But that being said, I'm so excited about this local sensors, and I believe they're going to help bridge the gap in actually providing the data required. However, with regards to the challenges, we would like to find out how do we power these things. Like, what sort of batteries do we need so that we can, stress test for like 3 months straight and don't be battery. I understand we have the solar panels. Another just one thing was also asking, like, when you send this to the open is it that the local census, there is once it's sent out there, like does it help to, interpret ingredients, or do we need to code it from our own end here to a certain standard, or is it being done automatically on the open AQ? But yeah, so those are the challenges that I see, and I hope that we can come together to actually produce real and credible data. So it's not that someone just come from some other part of the world and tells us, okay, this is your data. We need to be able to have our own data so that we can challenge and say, what is your methodology? This is how we came to that. Thank you.
Yeah, very much for the both of them. Very good to us in driving. Yeah, so okay. Okay, so they have been good in driving the air quality mission for us. So let's have a look again to respond to some of the comments. Thank you.
So, you're wondering if one sends in data to the OpenAQ system, if any data was, or will they do the analysis and so on and send back to you, or if you want it to be analyzed, or is it the raw data you're looking at? What's the question?
So what I is like once we've installed we have deployed the local sensor, we have only just deployed it, and we've done our own thing, and put it in our own local standards, Lagos State standard, federal standard. When it goes into like as in the X and Y, does it read does it read what it is in real time here, or do we have to hold the sensor, or is it just when we send it, it goes straight to the open AQ and then it gets the reading based on
the raw data, so you can base the real time. And then they can also help in the analytics aspect of it, like you said also that if we need to be trained, we can reach them. So they can carry out some trainings. And for instance, the one she's talking about at Abuja is the raw as it is. And so the analytics aspects of it, they can also handle. And so, and also the second speaker of today is also, they use machine learning like she showed. So that can be used to analyze the data for you if you need that extra service from them. So whatever you need from them, you make it known to them and they'll provide that. And if we need training also, they can also train us on the specific thing that we need to, the aspect that we need to be trained on.
So earlier on, you were asking the woman from OpenAQ about, if in the Abuja is it possible to collocate online? Can you do an online collocation, like if you mount this maybe Lamata HQ now, and then we'll receive data maybe to our database can be?
That's the kind of question I was asking her. If you can actually show that, if you know that this is where the reference monitor is, so you might not have to go and take permission. So you know that if I collocate just this is the location I can put that is close to this place. So with OpenAQ, you can see the location of the reference monitor and decide to locate and deploy your local sensor around them, close them. So you will be collecting the data from them, from the OpenAQ, and then collecting your own data. You can send your own there also to OpenAQ. So OpenAQ can have your data, have the data of the reference monitor. So you can use those two and do your co-locating, because this is the exact one that is coming out within that same time. So yeah, no, even if you're co-locating physically, it's the same thing, because all you need is data from that reference monitor. So you might have to look for permission from the US Embassy or for the owners of the reference monitor to get that data from them, to be able to collocate with your own, calibrate with your own data. But with the OpenAQ thing, you won't even need to go to anybody, because the owners of that reference monitor have decided to let it go, free to OpenAQ platform. So you just note the location on the map where that reference monitor is and decide I want to collocate without even the knowledge of the people that have
The problem with that is that how many people have this local sensors or reference points in Nigeria or even Lagos? So except we do a pilot and then encourage other people to come and collocate with our own devices.
Like the one I showed you, University of Lagos, will soon install. So from what she says, if we now let it go on OpenAQ platform, then you can.
Yeah, but from OpenAQ, like it's only Abuja that is.
No, for now, the only reference monitor in Nigeria now is only one in Abuja. The second one is in the consulate here. That one has broken down a bit, so we cannot get any data now. So before now, it has been only 2 reference monitors in the whole country. Outside what we now have in Unilag that we're yet to install. Everything is in place.
One last question. So, I'm so sorry. Once you finally go live in Unilag, and like as in you go on the OpenAQ, and I'm here in Push-Up, like what is the radius like as or it doesn't matter?
It matters. It matters when you're co-locating. When you're co-locating, you have to co-locate quite close to the reference monitor. That's why she said if you know where the reference monitor is and you want to co-locate, you can decide, oh, this is where it is. Let me go and put my local sensor close to that location, even without the owners knowing. So you can, if you have permission in the University of Lagos and you decide to even without letting us know, that's so we will know from OpenAQ, we will see you, but we may not know who has it.
Okay.
So
is it possible to bounce, so I can have one that should be here, have one that 20, and then if me I'm engaging here, I can bounce from one locator to locator to the
no. What you can do, co-location is 2 types. Either you co-locate with a reference monitor or you co-locate with your different local sensors, co-locate them together. So if you co-locate them and you calibrate with a reference monitor, one, for some months, you now know and you now have the factor that yes. So you can carry that one and co-locate with several of your own local sensors on your own where you want to put them together. And then you can use that one you calibrated to also work with it, because the other one is almost like a reference monitor since you have a factor. Yes.
Very much.
Actually, this I'm more interested. And I want to ask just 2 questions. Number 1 question is about the domain knowledge. Does it provide, or is it OpenAQ provide the training of domain knowledge so that when an analyst providing the LLM, they are trying to train the model and all that, so that it will be able, the machine learning will be able to interpret data accurately. So when you have the knowledge of data around you and all that, then you'll be able to know where to go on training the model. Then the second question is the contextual understanding, assembly method. So there are a lot of things that we would like to move from. So the data, do they have a template already on the LLM that we can use and we can tweak to what we want, already made template of the data that we can use on the data set and use to interpret data and analyze?
Dr. Davis there. So what I can say is Dr. Davis can train us on that. And also Collins can train us on that. So training is very important, capacity building.
Yes,
so,
I'm online. You can hear me?
Yes, Dr. Davis, please.
Yeah. So the only limitation with the machine learning models is the data. And once we have data, we pre-process the data very well. I can come in and we can train the models for air quality monitoring. So there is no problem. We can partner and do that.
So we will see that the ones specific areas were of interest so that training could start in earnest. So if you're interested, it's free of charge. Because they are my lead, I'm saying on our behalf. The last question. Just one. Oh, thank you. Yes. Yeah, because interestingly, apart from the World Cup, we also have lots in Lagos. Yeah, that you are not aware of. Yes, and your question, the open AI that you were talking about, yes, it's the API. API is like, it gives you the data, the graph of that data. So it just, if you go to lasepa.gov.ng, you've already done that for them already. So you could view the air quality data on lasepa.gov. So it's with our permission of Honorable Coach, transfer the question to you so that they will also view the air quality data on your website. So you have to indicate interest. We also incorporated it into the whole website. You can see, so. So, Lasepa.gov.ng Center for 21st Century. Also, no, the census. No, it's not really like it's yes. So these are platforms we have actually incorporated those data. So no matter if you are interested, we just write to enable lead. Yeah, so that they will not install it. They will just the API. The web will just install so that you could view 30 locations in Lagos on your website. So instead of going to the original website. So just like the OpenAQ, there's original websites. So you have that on your own website, free of charge. So I think we are done for today. Any other one? So let's have a quick closing remarks. I don't know whether our GM is online. Our GM, I don't know why he's online. Is he online? Yeah, he has been there for it. Okay, so let's have the representative of the GM. She's on board, she's online, she's everywhere. She's the one leading the forefront in installing those sensors. She helped us in getting those approvals, following us to locations. So a lot of applause for her, please. So all the sensors, she's the forerunner, pushing to make sure that the whole of Lagos is being covered. From the South Pole to the North Pole to the East Pole, all the poles. So let's have the closing remark. CEO representing the to close this. Then we'll also have our able Dr. Selga to give us the summary and also wrap it up. Thank you.
Appreciate everyone seated today. Thank you so much. Thank you so much. And also those who are connected to us virtually. Also appreciate every one of us. And on behalf of the general manager, Lasepa, yes, on behalf of the general manager, Lasepa, Dr. Batista Jani, my name is Ayodele Osho, Director of Air Quality and Emission Control Unit of Lasepa. And we appreciate every one of us for this gesture, especially to our academicians. And part of the agenda of our GM, Dr. Tunde Ajayi, is to collaborate with all academicians. So it's not only a meeting that we have that's to every university, state university in Lagos State, because we find out that without the researcher, the policymaker we can go smoothly in that, because we need research in so many of our agendas to ascertain, especially in Lasepa, for us to have accurate and reliable data. The researcher cannot be left out of this. And that's part of the agenda of the general manager, to just collaborate with all institutions and researchers, which the air quality monitoring group has been, I think we have been here for the past 2 or 3 years, of this research, and we appreciate you all, and especially to our co-agency in Lagos State. We thank you for this platform that you wanted in order for us to make Lagos State a better place for us to live. Thank you.
Another information I love you is that she usually takes care of people. For every trip we used to go to enjoy. So let's have the closing remarks from our tables. Pharmacist, she's an associate professor from the Department of Pharmacy. Dr. Sophia Olga has been with the airport. She's interested, she's a part of the she's a forerunner, she's always in front. She was here 12:20 when the program is for 2:30. You can see. So a round of applause for her, please. Clap, 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 clap.
Okay. Oh. I was just okay. But I heard him saying I should give the program back. I want to start by thanking everybody who has spent time to come here to make this program the success that it has become. And I believe that we, each and every one of us has benefited one thing or the other from the presentations that we have made today. So, if you didn't, I believe you have so many things to take home from the presentations of today, from the importance of AI and large language models and all of that. But most importantly, I believe you will take on the connection between air quality and air, because it's very important. And the reason why we are even talking about air quality at all is because it affects the health of the people. That's why we are talking about it, because if it doesn't affect us, then it will not be important. And so I think we should take the case that individually we should be working towards improving our air quality. In other words, we should be looking at what we can do as individuals to reduce what we emit in our homes, in our offices, for instance. So if we do that collectively, it will amount to something. And since we are in Lamanta, an agency of government, I will also say that the government has a lot to do to improve air quality. And I'm aware of the important things and the positive things that Lamanta is doing to reduce emissions from commercial and private vehicles, from rail line, blue and red, and all of that. But other than that, the government, state, federal, local, and any level, if we can get 24-hour electricity, I'm sure the air quality will improve very sharply, because then we will not need to use generators the way we are doing right now. So the fumes of generators will be drastically reduced from the air that we breathe. Every now and then you hear people who have died from generator fumes because it was close to where they were sleeping, and the main emission from the generator's carbon monoxide has no smell. It has no color. And so, especially when the people are sleeping, they won't even know that something is wrong. And the next thing, they cannot wake up. So if the government can work towards providing more power for the people, air quality will improve. And then if we have many people lifted out of poverty, they will be able to afford alternatives like solar or inverter, and that will also improve air quality. But right now, those things are beyond the reach of many or most Nigerians. So I think that the government also has a lot to do apart from individual contributions. One thing I also want to suggest is that we begin to promote the importance of installing smoke sensing devices and carbon monoxide sensing in our homes and offices, because it goes a long way. Like when a fire is about to start and you have a smoke detector in the environment, once the smoke gets to a particular level and alarm goes off, so the occupant of that building or wherever it is, we have an idea that something is wrong, and that can save lives. The same thing with carbon monoxide. Living in a house, due to fire or due to emission from some other devices, the carbon monoxide level goes up, an alarm is triggered, and the occupants will know that something is wrong and run to safety. So I think those two sensors or devices should be promoted and made available at affordable prices for people to install in their home and their offices. Having said that, I want to thank everyone. And I want to ask that you practice, that you walk the talk. That when you live here, you don't just go and say, oh, I attended air quality center. You should also say what was said there and take home what is one thing that are going to do to improve air quality. Thank you very much.
Just a quick one. I think, so we have in our midst the president of the Nigerian Slum Accident Federation, the president of Mrs. Bimbo, is around here with us. You might be wondering, why do we have her? Because we in our study we noticed that most of the air pollution slum. Slum. Oh, yeah, slum. Slum and
informal settlement federation. Affiliate of slum dwellers in segmentation. Wow. Good afternoon, House. Good afternoon. My name is Abimbo Esther Oshobe, the president of Nigerian Slum / Informal Settlement Federation, affiliate of Slum Dwellers International. Working with the university on most of their research and projects, what we've been doing, because our people need a lot of sensitization. Formerly, we were looked upon like riffraff. Now, what can they do? But in most cases, together, what we do, our major focus, which we call the rituals, is gathering data and then savings. We make our people to understand that you need to save today to save your tomorrow. Right. Either for your children, for your family, for your future. But you need to save today in order to save your tomorrow. Then we gather data on everything we do, because we believe that you can't plan for what you did not have the information about. You want to work in the place, or you want to work on a project, you must have collected data concerning that very project or the place you want to work in. So these are our major core rituals. So while we are working with the University of Lagos, on air pollution, in most of our communities, we use firewood. We use sawdust. We use corn back, that's the shell from corn, in order to make fire, in order to smoke fish for the ones selling fish. Then, when you talk about air quality, you know that all these things that are being done have great effect on either the person that is being and the people around that area. So we go on a lot of sensitization, like telling them that there are other ways to do this things without putting the objects are bringing out smoke. So we have some of these NGOs that brought in the idea of using ethanol to power stove. The idea of using paraffin to power stove. So we've been collaborating with them and we've been sensitizing because we actually need it. You're working for something because you want to have something from it. You're laboring for something because you want to achieve something out of it. So whatever you're laboring for that can cause high effect on you, you have to make sure that you reduce these things in order to be able to get out of the labor of your life. So that's how we're working hand in hand with them to sensitize our people on air pollution and how to go about it. And we equally told that we would like to have some of these sensors in our communities. Because already we have big sensors in our communities that have to do with climate change so that it can read the peaks if they move forward. Thank you very much.
You can see that it's been done. Our awareness creation week was done in Diego Bariga, trying to go to the rural areas to inform them, stress areas of policy. So we are doing a lot for Lagos State. But I think we'll just come to an end and I will lead any other thing for today. So we'll just close.
My closing remark is a song. A song that I like. I was taking us and now he will continue to take us. I appreciate everyone, especially as I appreciate the MD of Lamata and the staff of Lamata, everyone that came here, the students, every sector, the journalists, the media house, everyone is appreciated. So we'll not go without taking a good picture.
So if we can, let's go downstairs. So let's go downstairs to take a group photograph with the MD Lamata. So and we have group interviews with the lead and also with the